and welcome officially to this session on panel data.
Transpose rasu. And kutur damo transpose hone malet and kutur ka matrix andu yalle andu transpose hone malet yaw matrix rasu no.
Please participants mute your please participants mute your speaker and try to focus on the training. Okay. So I am Nagajugu from Bahar Dar University Department of Economics. Welcome officially to this session on panel data analysis. Our speaker today will be Dr. Getachew Yirga of Bahar Dar University Department of Economics. Before we officially launch the session, before I invite the speaker, let me say something about our speaker, specifically the professional career of our speaker, Dr. Getachew Yirga. So Dr. Getachew Yirga is an assistant professor at our university, Bahar Dar University currently. He's giving courses for PhD and MSc students, and he's examining a number of students at our Department of Economics here in Bahar Dar University. Let me mention some important points about the professional career of Dr. Getachew Yirga. He graduated his BA degree from Bahar Dar University in the Department of Economics, and he also graduated MSc from Addis Ababa University, and he do have also another MSc degree from Namur University, Belgium. And he also graduated his PhD degree from University of Verona, Italy, with PhD in Economics and Management. By now, he is a visiting scholar at the Department of Agriculture and Applied Economics, University of Kingston-Madison. And currently, Dr. Getachew Yirga is a consultant at World Bank, and he is also a consultant at FAO, two big names, two big international companies working on development endeavors. By now, he is a scholar Please participants mute your speaker for the time being. I am supposed to speak and they are supposed to hear, to listen me, so that everything will be in a harmonized mood. So to mention some of his professional experience, Dr. Getachew Yirga is a senior economist at Bahar Dar City Structural Plan Preparation Project Office, research fellow at the Institute of Economic Research at Bahar Dar University, research member Hunger for Trade Project, and finally is now working as an assistant professor at the Bahar Dar University Department of Economics. He engaged in various research activities. The following can be mentioned regarding his career. So, has an enormous publications with regard to development economics, and we can mention him as a big name, or we can consider him as an important scholar in the area of development microeconomics, specifically in analysis of poverty, measurement of poverty, and analysis of microfinance effect on development, and impacts of social protection also. And he has a wonderful talent in managing Stata, specifically panel data analysis. So today, our speaker will be Dr. Getachew Yirga. Everybody, are you hearing me? So let me invite Dr. Getachew Yirga for today's session. So participants, please mute your speaker, please, once again. Participants, please mute your speaker, so that we can listen attentively. Dr. Getachew? Are you hearing Dr. Getachew?
Yes, Naga. I heard you right.
So the podium is for you. You can start.
Very much. Thank you, everyone. Thank you, the organizers, Untitled University, and other co-organizers for this opportunity. I really appreciate such kind of training, and it's a very good opportunity for me as well to speak on such occasions. So I will directly go to the short training on pattern data. And let me try to share my screen, but it seems that I'm not able so far to share my screen. Can you confirm that I share my screen? So, okay, panel data econometric models are actually very complicated, and they are a lot, and we will only focus on, because this is a short one, linear panel data ones. And we have the following issues to speak in this short hands-on, maybe not hands-on, but training along with the Stata. We have to first talk about why we have different types of panel data models. And those types of panel data models are actually motivated on some issues that we are going to speak in a while. And basically, we have a lot, but we will only focus on three in general: the pooled oil-less, fixed effects, and random effects models. And we have to also at some point make a decision or give the hand to our data to speak, and make a decision on the choice between alternative panel data models. For instance, we have to,
Excuse me, Professor. Your screen is not visible.
really?
Please reshare the screen.
Dr. Getachew, please share your PPT.
Oh, sorry.
Your screen not shared.
When I said confirmation, somebody wrote yes, and I thought I already shared my screen. But still, I seem to face a problem because it says connecting. And
Sir, yet your screen not visible.
but it should, right?
Not yet, Dr. Getachew.
When you say visible, it does. Okay.
See at the bottom, there is an icon in the upward arrow sign. Click there. Then select screen one.
Yes.
Then share.
Yes, I'm doing that, but then it says connecting, but it's not.
Okay, it might be a connection problem.
I may suspect that.
Shared, sir. At the bottom, there are some icons, and one is to share the screen. Upward arrow sign is there. Select then. New window will open. On the left hand side, there is a screen 1. Select it. Then share.
Yes, I tried that one, but it's still saying connecting.
So, the problem
Network is
for
fine, sir. Network is fine.
For now, okay, now let me.
It seems to me there is a network issue. The solution is you can send your presentation to the moderator. He will control. Send on his email address. He will share the screen.
Isaac Ogayo, can you help us, please, in sharing the PPT or the file? Isaac Ogayo.
Okay. Entire screen share.
Dear professor, I am asking, please send your presentation to the moderator. He will share from his
Okay.
side.
It now seems that
Dr. Getachew, the moderators are asking you to rejoin once again. Leave the meeting and then rejoin again.
okay. Hello?
Hello? Hello. ላከልህ ማቴሪያል? ሄሎ ማቴሪያል ላከልህ? እሺ እሺ የኔን አንተ እስከዛው ድረስ ብዬ ነው።
Yes, dear professor, your screen is visible to us.
Thank you so much. I'm sorry for the inconvenience.
Yeah, it is fine.
Now you can continue.
Yes, yes. Now you can start.
Thank you so much. Let me maximize this. So the
Yes, it is now in full size.
thank you.
Fine, fine.
So we have to first discuss about the motivation behind for the various panel models. Basically, there are lots of panel data models, but we will only see 3 or 4 of them here. The first one, and something that is ordinary, is coming from the OLS, and it's called in panel pooled OLS or pooled regression. And the other and widely used one is fixed effects model, and we also have random effects model. At some point, we have to make a decision between choosing the alternative panel data models for our data. And one of the ways of doing so is comparing these, particularly the ones that you see here, the 3 ones. Pooled can be compared with fixed effects model, and an FTS can be used. For the choice between ones, actually, we make a decision at this point. And if fixed effects is chosen, we also have another choice for the random effects model. And Mr. Hausman will come here, and we can use Hausman specification test to choose between fixed and random effects model. We will see all of these in a quick way using real world data from Ethiopia using Stata. Let's directly dive into the motivation. Researchers, as development economists, are very eager in different types of analysis that actually based maybe they may be interested so these are actually speak for pooled data time series of cross sections where the same observations or units or households, for instance, are followed over time. So if we have 30 households followed, they could be followed every year for 5 years, for instance. So you have 30 by number of observations if you join them together, and that is panel data. But the time of observation for each individual unit or household, for instance, could be different. Some households may be providing data for instance, 5 years. Out of the 5 years, some may provide data or maybe observe it for 4 years, others for 5 years, others for 3 years. And if we have set type of panel data, then that is unbalanced. We don't have the data that's observed, want it to be balanced. I just assume those are actually we have the observations, the individuals or firms or households observed similarly, simply balanced. These are actually some of the advantages of using panel data. Obviously, you may probably have a look at one of the problems in cross-section data is individual differences. So heterogeneity is explicitly accounted. If you have panel data, individual differences can simply be captured when you have panel data. It's also possible to capture both attributes that change over time and that change across cross-sections, so for different observations. At the same time, it gives us variability because multicollinearity, as you might remember, is a small sample problem, and when you have that, variability is a lot, and the probability of being known to one another is reduced. You will have more degrees of freedom, less collinearity, and efficiency is the one that you may also actually need to attain at the end of the day. But out of this, an important motivation is heterogeneity, or what we call country-specific or household-specific or individual-specific attributes that actually are not observed. Attributes can be observed, but when they are not observed, they are heterogeneity. They are latent and unobserved individual differences. And the play is the motivation behind the various choices, the various types of panel data models. So the choice of panel data models depends on whether actually, technically speaking, these individual differences correlated with the explanatory variables or not. So those are explanatory variables are observed. There are unobserved individual differences, which we now call heterogeneity. And when these two are correlated or uncorrelated, we give you the various types of panel data models. For instance, if we assume that, or if the correlation between heterogeneity is assumed that way, and if it's assumed that way, it means it cannot be correlated with explanatory variables. Then either random or OLS can be used. Let's try to look those highlights in the XYZ variance in the general. So we have two prefixes here. This is the dependent variable, and there is I is capturing the cross-section component, and T is capturing that the time series, the time component. So we have explicitly observed explanatory variables with their corresponding parameters, vector of parameters, and these are actually those that do not change over time, but in individual differences that are observed. Or, of course, we will discriminate these two into two. And these are actually those that we don't observe. But this is the very difference. If we have cross-section data, you don't have this. Or if you have time series data, you don't have this. This is something that you find in panel data. we have this happening through what we already called individual effects. But V can be two. Okay, we can observe them. These are not changing over time, as we said. For instance, these variables do not change except location, which may change over time, but usually it is not. And okay, this is fine. Okay, if it's observed, we are safe. The problem is when ZIs are or a part of or all of VIs are unobserved. For instance, while we collect data on myself, we may not collect data on my family. So characteristics of myself may not be observed. Somebody, okay, while collecting data on my educational achievement, it may be harder to collect data on skills. Okay, so or preferences, for instance, for that matter. And these are actually the very important variables or list, vector of variables that will actually be the difference between panel and other types of models. Okay. For instance, in the wage education model, we don't usually get data on ability, and if it's missing, then it goes to error term. It's obviously endogen. So heterogeneity is one cause of endogeneity, and we have to use panel for that. So panel data is one way of solving the problem related to heterogeneity or endogeneity in general. So the various types of models, competing models, are actually used to estimate the Abel general model. If we use simply OLS, the ordinary least squares, where actually that Z here, the constant term, if it's constant, then it's gone, because this is also constant. If it is constant, then it's the same for everybody, and we won't have any difference between OLS and panel data. Then we simply call that pooled OLS or pooled regression model. But then, if VI are unobserved, again correlate with one or any of the explanatory variables, then OLS will be balanced, and it will be obviously in the large scale, in large sample, it will be inconsistent. Then this will be the fixed effect that we will generally have. So for every so we are just letting the Zi alpha into alpha I, because this is also vary. So everything that you have here is capturing individual variables which are not observed, but then we are suspecting them to correlate with one or more of the explanatory variables. So we have to basically technically get alpha I estimated. So we need to have a group specific constant that's going to be estimated. But there is a trick that we cannot get this, because for every observation, for every household, we cannot get an estimate. This is something fixed effects model will actually get a trick for us. Random effects model actually just trying to build the LLM. So let's get to the related of these in a little while. So the other alternative model could be random effects model. Again, we have no observable visuals, but then these are assumed not to correlate with the explanatory variables, which then means, okay, we something that, okay, the eyes are there, the visual differences are there, heterogeneity is there, but then cannot correlate with the explanatory variables. This is the assumption. Okay, this may not be data, but we may sometimes have to, I mean, our data in such a way that we assume our the correlation between this and any of them. Then we will have components here. One is something that in oil, but then you have another component that actually is varying, and yet not varying with time, but then not again assumed to be this. So we have two errors, okay, two error components. Some people call it random effects model double or two error component, multiple error component model, because it has this error component, which is not varying with time, this error component, which varies with time. Again, both vary across of it. So the distinction, may now notice the distinction between fixed and random effects is not because something is fixed or something is not, but because of the correlation or the uncorrelation of the unobserved heterogeneity with one or many of the explanatory variables here. Okay, so let's see the estimations in relative detail now. Let's begin from pooled OLS. So we're going to add flesh to our skeleton. So the pooled OLS takes all the assumptions that we know from squares. Basic are, for our purpose, are these ones that we see here. And basically, we want this to be constant for everyone. Okay, we don't have something that is changing with somebody or some group or some individual, some house. We can say this model by using OLS, and it's called simply pooled OLS. But we may also tend to choose a more efficient one by just making a trick that, okay, let's assume that, okay, everyone has his or her own heterogeneity that's unobserved, but let's average them out. Okay, let's take an average of those, but typically to be giving a different result. But again, it's one family of pooled OLS, and econometricians call it population average or P. See this feasibility general squares, they call it pooled FGLS. And that is what we saw here is the fixed effects model. Obviously, that the unobserved heterogeneity is related with the explanatory variables in fixed effects. And in that sense, then all pooled estimators, either population averaged or simple pooled OLS, or for that matter, if you also use others, which are in the pooled family, will be both biased and inconsistent. So one way is then to apply fixed effects model, as we already said earlier. How does fixed effects model then be estimated? I mean, how do we estimate fixed effects model? Some people call it within effects model, and so there is a between effects model which is over here, and it's not widely used because you need to have longer time observations for that. But we usually, in developing countries, we have a very small sample panel, I mean, of years, and it's not usually estimated. So within effects model is widely used. So fixed effects model, as we already said, there is a correlation between this and this, and we will estimate each this. We are by just literally speaking, estimate this, but not practice. What we will estimate a transformed model using OLS. OLS still is used, but on a transformed model. How is the transformation done? So from each data, for instance, in the dependent side, we will subtract a mean that comes out by just doing this. Of means, one is by dividing certain observation, I mean, the sum of observations by the time, the total time that is used, or by just dividing the traditional one, as we already know in cross-section, by just dividing the number of observations, the number of households, for instance, or by dividing both the product between N and T. But in order, what we do is we will first demean, first calculate the mean here, and demean here. Okay, so the mean is simply something capturing the cross-section component only, because the time series component is already summed up here, taken away. Then we will subtract from each here, from each observation over time, I mean, a variable that is constant, but not for every observation, but constant for the time period that we have. So we do the same thing for the explanatory variables. We do the same thing for the explicit error. In so doing, we will be kicking out, I have to go back, we will be kicking out that component that is not varying. The fixed model was started here, and we will be removing this because this doesn't vary with time. So the thing is, we are strategically kicking every individual heterogeneity or individual specific variable that is not observed. Actually, the challenge is, or the shortcoming is, we will also do this kicking out for those that are observed but not changing over time. For instance, doesn't change over time, but then it will be taken out. But then, okay, as a solution, we can interact. We can interact time invariant variables with those that change with time, and then we can have a solution for that. But in any case, fixed effects model will be throwing away unless you do this thing, those that do not actually change with time. So this is a kind of long-term model, but the short time will be kicked out. And random effects model, as we already said, doesn't acknowledge the correlation between the unobserved heterogeneity and the explanatory variables, but it acknowledges the presence of heterogeneity or individual differences. But the thing is, this is a very important assumption. UI, actually this should be UI, and yes, UI is here. This is something traditional, something that we also get from panel, I mean oilless. But unique to random effects model is UI and the explanatory variables, any of the explanatory variables are not correlated. Actually, this is within the assumption of strict exogeneity. So the very difference then between random and fixed effects model is that in random effects model, we assume basically the one that you already said, we assume away the correlation between the unobserved heterogeneity and one or more of the explanatory variables, which is actually similar to pooled LS. Actually, pooled LS doesn't do this, but it's because it in the very first consider these are changing over time, but they are changing for every observation. I mean, not time, but they are constant. But again, technically speaking, you can say that this is equal to 0. So why do we go to the random effects model and not the pooled LS if we do that? The argument is from econometricians, we get more efficiency by considering these double error. So as you see here, we have a double error here. So the serial correlation between these two double errors is considered in a kind of extension of OLS called generalized squares in random effects. Use the GLS to take into account the correlation of the two error components. But OLS, by its assumption that this is constant, ignores this correlation. Okay, it only considers the error coming from this component. So as I say, it is because of these error components model, random effects is called error component. You can construct random effects model by just dividing the two. Okay, the technique of estimation of the random effects model is by just constructing what we call the big full ranked variance matrix, which actually is coming from the two errors, the one coming from unobserved heterogeneity and the one that coming from the traditional error. And this is going to weigh the OLS. Okay, so the application of data that weight being will actually give you the random effects estimator. So this vector of betas will be actually simply called random effects, or some people call it, or Stata even calls it GLS. Even if you can also get a maximum likelihood estimator of random effects, or usually the one that you use is generalized least square. So generalization is just using this, which is this, as a weighting variable. So we are almost there. In theory, we have to make a decision, okay, between pooling and pooling where we don't have any individual differences, and fixed effects model where we assume individual differences are there, but then we don't, we assume also these individual unobserved heterogeneity or differences are correlated with the the explanatory variables. So the choice has to be made on these two models. Okay, our data then can be used to test to estimate this F test with this much number of numerator degrees of freedom and this much number of denominator degrees of freedom, which is actually going to be compared with the critical F statistic. When we compute our calculated F using the two. Okay, so we estimate our, basically Stata will do it very, very easily, but technically speaking, it should be done this way. With the R square of the fixed effects model and the oilless or the pooled regression will be compared, and they will be actually standardized using these degrees of freedom. Actually, this is also used as a denominator. So we will take this as null hypothesis. The null hypothesis for this test is that pooled oilless is consistent in the sense we, as we already said, we don't have any individual unobserved heterogeneity. But then if we are able to reject these null hypotheses, obviously we go to the alternative that fixed effects model is consistent and efficient. So we go to here. We will very easily look at this based on, using Ethiopian data later. Lastly, we have the choice between, okay, in this, for instance, let us see, we have an F test favoring the null hypothesis, the alternative hypothesis that fixed effects is favored. And then what we are saying here is fixed effects model is there, but then fixed effects model is just saying, as we already said, the unobserved heterogeneity is there, and it correlated with one or more of the explanatory variables. But you may have the option of assuming away that correlation. Okay, one thing that we note from the fixed effects model is there is unobserved heterogeneity. Good. Then the next step is, what if we, assume or not of the correlation between these unobserved heterogeneity and one or more of the explanatory variables in the model. So random effects model is, as we already said, is another candidate within the effects family of models. So Hausmann is here to then discriminate between fixed or is in the null hypothesis, because the assumption is clear. We assume away the correlation between unobserved heterogeneity and one or more of the explanatory variables, but a certain non-zero value is considered based on the data when we have a fixed effects estimator, because fixed effects are, as we already say, takes a certain non-zero correlation between the explanatory variables, one or more of these, and unobserved. So what the Hausmann test statistic computes this simple statistic, actually not simple, but when it's done within Stata frame, it's very simple. So it's a matter of comparing parameter coefficient estimates and asymptotic covariance matrices. Okay, but then it should be compared with a chi-square critical statistic at the number of parameters at actually degrees of freedom. These are actually the ones that I brought for this session, the simple linear panel data models that we usually use. But then panel data can be extended to a lot of issues these days. So if you are interested, we can have a static panel data instrumental variable estimation, which is actually taking into account endogeneity in our panel, and XTIV can be used in Stata. And panel data can also be dynamic in the sense you can have, as we already saw in time series by itself. I mean, dynamic, you can extend that to unit root, for instance, co-integration. You also saw that, and their correction in time series, but they can also be extended to panel data. These are some of the things that use in Stata, the command, some of the things that we will later use for our application. With that, I conclude the theories part of the training, the short training on linear panel data, and we will move to the applications using Stata. But if you have any issues on this, I am open here. I don't know the format of the training, if it's or we can, I don't know, raise questions later. It depends on the organizers. Where is my, I hide it here. Okay. Any confirmation? May I proceed? Hello? Okay, thank you, Shaq. I can see that. Okay, but sometimes I may think that I am presenting, but I may not. So this internet thing is a trick. Okay, so let's open, let me open, because this is not a hands-on training. And let me open my Stata and try to show you some of the things that we already said, saw. So I am that kind of guy who uses the do file for presenting or estimating results. And I already have everything in my do file here. Otherwise, you can use these menus, as you already know from your training, this in this training, in other trainings, or in your previous exposure to Stata. You can use the menu here. You can use the command here, and optionally, you can use the do file here to send to your Stata a job. So I use my do file here. So my do file is in here, and I will be opening data there. And this data is real data that I extracted from the Ethiopian. Okay, let me actually maximize this, add a little bit of font here. It's 12. I think I need to make it 14. So this is the real world data from the former Ethiopian rural household survey. In the survey, the two rounds, the 2014, the 2004 and the 2009 rounds, for a paper that I published at the Ethiopian Journal of Economics. And I already did that because this is a rural survey. So I extracted that one only for the Amhara region. So let us see this data a little bit. Because as you know, before modeling, you need to know your data, because when somebody collects a survey, then we have to their data, maybe and looking at the various data files and trying to merge, trying to create some other variables and stuff. So this is actually not part of this training, but I already managed the data and identified a panel data, but we will see that later, that actually fits to our small training. So the first thing is in panel data, the first you have to say your panel, your data is panel data. So you have to declare to Stata that you are going to use panel data. The default cross-section instead, you may probably do that with software on time series. You have to also state that when you use time series, you have to also state you are using time series data. So the way of doing that in panel data is also in the 6. If you use the menu here, you have the menu beginning with down here longitudinal or panel data, and we have to, when you come here and you declare data set to be panel data. So a box opens with this thing. For instance, it's already known to the Stata, so I will use unique ID and year as panel and time variables respectively, and I will simply click on submit. And in the do file, I do this. I will tell my panel, my Stata, this, and it comes with a note that this is a balanced panel data and strongly balanced, saying that, okay, every observation, we will see the number of observations later. In fact, we have 732 totally pooled observations, but half of things we have 2 years. In every year, we have half of 732 here. We will see that later. But Stata also tells me about the year, the time variable. I have only two time variables, 2004 and 2009, but there are some gaps here because Stata is saying gaps are between, okay, obviously 2004, it doesn't say 2005, 7, 6, whatever, but it jumps to 2009. Let's summarize our data as well, so that we have some clue about the mean of some of our observations, variables, and relevant, in fact, variables, because this unique ID is irrelevant. We have also year here. We have the, actually, this is coming from an old data set, and PA is Peasant Association. HHID, age, for instance, is, this is a so we have a household head, and that is ranging between these two. The squared age, bank account, okay, bank account, we'll describe that later. Consumption data is also there, credit, distance, drought, education, household size, land coverage, gender in terms of male head, marital status, and others. Actually, we will only use some of these in our later estimations. For instance, we will use the number of oxen here. Okay, poverty, we may use it, but not for this purpose. And the real consumption, remittance. Okay, total livestock units, TLU. They are here, and okay, for the description of the behavior, I did, for instance, if you look at something, we know our little create is and distance is distance from the nearest town in kilometer, because this is the rural data. Drought is prevalence, in fact, one if drought happened in the past 5 years, and education is the grades of schooling. So this is actually for adults aged 15 years old. And a cope is dummy as well. It takes one if any household member is a member of a cope. Household size is clear. Male head, okay, is one if the head of the household is male. Zero otherwise. In fact, otherwise is female. Then it's clear the total number of oxen. If you see oxen, it means one in oxen. But real consumption expenditure per capita is also here. This is per capita. So just dividing the real per capita expenditure by the total number of the total household size, and that is in 1994 prices. The real is constant. So we have this data. The thing is, we will actually motivate our model in a while. The thing is, we don't know. For instance, you have 700 observations, 732 observations here, but you don't know which year, I mean, how many observations in each year you have this data. For instance, for age, for instance. So we need to know further, because this is panel data. So, okay, there are other panel data commands, but you can use them. But I summarize our data by just sorting by year. So doing that for the first year, for instance, for the year 2004, we had 336 observations. So we have a balanced panel data of, in fact, 336 observations followed after 5 years. So the first, actually this was not the first, they were interviewed in 2004, these 366 in Amara region, and then after 5 years, they are again re-interviewed in 2009. So we have, okay, now the previous mean age was 53, but now 52, if I remember it right. That was pulled, okay, but now 53.6566 in 2000. And then 9, but in 2002 that was 51.3. In the average was this much. plus 1100, but then it was less than 700, 660, 670 in 2005. So there was a jump. Actually, the inflation might have attributed to this, but if we have the real one, for instance, the real per capita, for instance, it was 118 in 2005, but then it was 64. So in reality, the per capita consumption fell over 5 years. Okay, in rural Amhara, there was in fact, technically speaking, there was between 2005 and 2009, for instance. So even if that was the nominal was rising, seems to rise, in reality, in real terms, there was a fall. So after you understand your data, you go to interpretive, the model's results. What is our goal of modeling? I want to model what factors are behind. In fact, this is going to be a big issue where we are now assuming away the problem of endogeneity now, but are also using the data, that problem of endogeneity that arises from heterogeneity is going to be captured. But any other endogeneity, actually, other factors, critical factors, for instance, or simultaneity between consumption expenditure and behavior, not so affect household consumption expenditure in Amara region, in rural Amara region. Let us say we want to, provide a mix of demographic, socio-economic variables. Some may be, for instance, some drought could be something that affects the whole community in a certain pedant association. So age squared, bank account, presence or absence, credit, again taking a credit or not, distance from the nearby town, drought, again educational achievement in years, family size, number of oxen, getting a remittance, and gender. So we are now having those explanatory variables explicitly, but then, as you already know, we have the error. But consumption, as we see, the data is simply in monetary. So I'm trying to converting that into a logarithm in such a way that we will interpret each explanatory variables in a kind of percentage point. Okay. A vector of variables together, that is done just by the command global. Actually, you can use also local, and I will create a vector of these variables. Okay, so that's what I do now. And let's estimate our pooled OLS. Okay, that is the first model that we need to estimate. What we do is simply the one that you know. This is simply regress. Okay, this is the OLS. Very good to adjust okay, so we use the cluster standard tiers, and we use unique ID to adjust our standard tier. Integration, you don't see the traditional results at the top here. Otherwise, it's all the same. We don't have this because we have used a clustered, okay, robust standard tiers, and you don't see the ANOVA table here. So we have the pooled, okay, we have all of the 732 observations used, and the model overall is significant because the p-value related to this F statistic is very small, and the R square is almost 40%, whatever. And we're now estimating a nominal consumption expenditure. In fact, we could have used the real one. I'm just demonstrating. And we have the coefficients here for each of the explanatory variables we used. You already know that how to estimate, how to interpret the significance or non-significance of each of the explanatory variables. I don't want to get with that, but we simply look at the p-value. I'm very straight to the p-value, not the t-value. So the t-value here is too high, here also too high, so I'm not going to estimate the 2h, interpret the 2h. The back count seems to be significant in since we are now having these coefficient significant, you may give it interpretation. But you have to take care. Okay, this is a land consumption expenditure. You are not saying, okay, having a bank account will result in increment in land consumption by 0.28. No, we have to use. I actually bring a detail here. For instance, having a bank account will be raising our monthly consumption by 32 plus percent. And this is actually the formula to adjust the 0.28 here to 32 or 0.32 here, because this is going to be adjusted. So some kind of exponential function has to be used here. In any case, whatever you have a coefficient that is significant, you will interpret as marginal effect, obviously. Even if the changes, whatever, are expressed in terms of percent, they are still going to be interpreted as marginal effects. We are not going to give or compute marginal effects as you used in logit or probability stations. So this is a simple pooled OLS estimation. What if we average out the individual differences and get results? So that was what we already named population averaged model. Stata computes the population averaged model using a different command called exit-to-reg. So we'll use the robust standard error estimation. Then the option of PA to refer to population average has to be added after comma. This one can be cannot be there, I mean, may not be there, but we are suspecting some kind of heterogeneity, and we are just taking into that account. So the PA is estimated this way, and everything is estimated similar to that one. Okay, interpreted, I mean, similar to the one that we grouped to, I mean, give to the estimation of the interpretation of pooled wellness. But there are some preliminary notes here, which actually you don't see in pooled wellness. So we are using some kind of grouping because we are averaging. Okay, so some notes are here that can actually be easily understood. The other one is fixed effects model. Actually, we don't usually use the population averaged one. We jump to we alternatively use pooled fixed random fits, as long as your interest is linear panel data. Again, exit-to-reg is used. Exit-to-reg is used, except that we change the PA into FA to refer to Stata. When it looks at FA, it automatically understands it as fixed effects model. But then we have to use, again, a different, rather than robust, we have to add the cluster. I prefer when I use the, actually Stata cannot allow to simple when you use FA. So we use that one to estimate fixed effects model. So we have everything run here, and we have this thing here in our results table. The thing is, we have the fixed or the between, I mean, the within regression. But then we have two types of R-squares that are very important here. And since we are now using the within, much of the within information, we will be more interested in this one. This actually is the same R-square that we know, the explanatory power of your explanatory variables in explaining the variation in the dependent variable here, the load consumption expenditure. But then the reason is coming from the variation within households here. But there is something that comes between, okay, the time component. We have a trigger information. It also has something to say. So overall, out of these, the weighted, the overall R square is the weighted of the weighted R square of the two. We have that one. Very important is this one. As long as you have that note in our theoretical session, that the correlation between the unobserved heterogeneity and any of the explanatory variables is assumed. And it is assumed to be non-zero. So that non-zero thing is now negative 0.067. But we don't know if this negative 0.067 is significantly different from 0. Fine, if this is significantly different from 0, we will keep on using fixed effects. If it is 0, then practically it means either oily or random effects. Okay, so it's up to us. But for now, we know that there is a correlation in our data. The data is saying there is a correlation, negative correlation between these unobserved heterogeneity and one or more of the explanatory variables, and that is estimated as that one. The coefficients are again the same as in the interpretations that we gave to the pooled delays. They are marginal effects, computed as marginal effects. And we have other estimations here at the bottom. These are actually observed and unobserved. Sorry, either the sigma u is related to the unobserved heterogeneity, and the sigma e is related to the error term, the traditional error term, if you want. So this will actually give you the share. Okay, out of this, out of the total error that we have, almost half of the error is coming from, okay, fraction of the variance due to the unobserved heterogeneity. So it seems that, okay, the unobserved heterogeneity seems to be a lot, containing almost half of the variance related to the overall variance. All the rest are the same. Okay, there are some notes here which some of which we already said. Okay, for instance here. So let's decide first. We can actually move to random effects and come back to the decision. But let us say a word on which model, because we already now have either a pooled or a fixed effects model, okay, taking away the PA, which is also family of the pooled family, the pooled regression. And let's make a decision on which panel data model to choose from out of the two. Okay. So it's a matter of, in our node, it's a matter of estimating this thing. Okay, so this is going to be estimated now, and we will make a decision on the choice of that. So it's a matter of regressing this thing, the previous FE model, but without, the trick is this, without the error, I mean, without taking into account the robust standard errors. So Stata will give you, if you execute this, Stata will give you sorry, my Stata is stacking. It's my browser. Okay. So if you go to the results window, what we see is the same thing as the previous fixed effects model. Everything is the same, except that at the end, there is a line with an estimate of the F test that all the unobserved heterogeneity are all 0. This is actually the null that we already said earlier in our theory. Pooled OLS is consistent. This is what we are now testing. Okay. Okay, the thing is, okay, the alphas are now used here in Stata, And that if statistic is computed as 1.58. However, this small is, we have to, okay, we don't have to refer to this, but we have to refer to the p-value. Okay, if you look at your critical f at any of the back of any statistics or econometrics textbook, for this, if you look at the critical f for this numerator and denominator degree of freedom, you will get something lower than 1.58, because I mean it's because of that the f is, I mean the p-value is so small here, indicating that we can reject the null hypothesis, so that the alternative of fixed effects is preferred. So our data is saying, okay, the data can better be estimated in fixed effects than in pooled. So it's I mean pooling is rejected. It's better to estimate at this point until we have a decision to be made for the fixed effects and the random effect choice. We have now obtained a decision that the model, okay, compared to pooled OLS, fixed effects is better. That's what we see here. Now, before we also choose a decision, I mean, make a decision for the random or fixed effects, let's first estimate the random effects itself. So the thing is the same thing as in, I mean, at the previous ones. The change here is simply RE, and we simply estimate this. And if you go to the results window, we get our random effects model here. So you may notice something different. So here is the very clear difference between fixed and random effects, as we already saw in the slides. The correlation between the unobserved heterogeneity and any one of the explanatory variables is assumed to be 0. And Stata is noting that for you. We are assuming this. All the rest seem to be the same, except that we have the GLS and not on GLS, and yeah, everything is the same. You give similar interpretations, marginal effect interpretations to your explanatory variables, and you get, okay, in random effects, the component of the variation in the error term that is coming from the unobserved heterogeneity is smaller. The majority seems to come from the traditional error component, which is E here, epsilon. And lastly, we have to make a decision again, as we made a decision between pooled and fixed effects. We said Haussmann is going to be used to discriminate between random and fixed effects models. And we already say the null hypothesis is random effects. So the thing is, okay, we first the procedure of executing a specification, outcome specification, is the following. We execute, okay, this quietly is, okay, I already know the result, so I am asking Stata to not report the results, but simply to store my fixed effects as fixed. I'm just giving this name. Otherwise, you can change it. And once I store the fixed effects results, I execute the random effects. I run random effects and I store it as random. And then Houseman is gonna compare the two. So I have to execute all of this at a time. Okay. So my execution began here. So we don't see the fixed and random fixed results because we already saw them, but we have the Houseman estimates here. But we don't need all of these details. What we need are this. The results just at the bottom of the table. You may simply look at this is simply a chi-square result, and actually I only focus on this, the last p-value, irrespective of the size of the chi-square. This is what you need to interpret. This actually will tell you whether to reject or fail to reject the null hypothesis. So what is the null hypothesis? There are some notes here. We already know that, okay, the null is here. Okay. Differences in coefficients, not systematic. Okay, this may not be clear for someone who is just looking at panel data now, but in the slides we already said this is the null. Okay, the random effects is consistent and efficient, which means that in the null hypothesis, random effects model is going to be preferred. So any rejection of this null hypothesis actually will lead to the other one, which in fact is fixed. So the p-value is closer to 0. So we are rejecting our null hypothesis of random effects at 1%, okay, at lower than 1%. So the null hypothesis of random effects model is rejected, and we will favor the fixed effects model. That's the simple thing that we notice from our data. Okay, I prefer reporting results, even if, okay, now we are going to interpret, okay, based on our previous F and Houseman test results. It seems that our data fits to fixed effects mode. So the data is speaking by itself. Okay, I prefer fixed effects model. So we will be interpreting the fixed effects results. So the marginal effects and other overall model estimations will be based on the fixed effects model. You have to show, okay, if it were a publication or if it's a thesis that you have to write, it's better to provide a table of your alternative estimations. Okay, that actually gives your readers better your better understanding of the data. So I'm just reporting using estimates table command of Stata. I'm just reporting everything together in a same table. And it's a matter of doing the same procedure as we did in the estimation of Houseman. So I will quickly regress every alternative model and save it as whatever name I give, and then I will estimate table and recall all the names that I previously gave. That actually will give us a table with stars. You can also report the standard years, whatever. but I didn't do that. So the pooled is here. The population average model estimates are here. The fixed, which we are going to interpret, are here. So the significant variables are these ones. Okay, for instance, distance, the road, education, household size. What else? Remittance is also important, positively affecting the change in expenditure. And yeah, these are the very important variables. Actually, this is not a formal research. I'm just doing it for demonstration. I already used the data from my previous research. So the random effects model is also reported here, but it may give you other variables that are not significant in fixed effects. But okay, more or less they give us similar variables, but they seem to differ on, for instance, on bank account and credit, for instance. Other statistic, for instance, the archaic information criteria, the R squared, the between, the width estimates, the overall are also here. They are reported here because we list them here. I list them here. Okay, in the list of stats, I just put jam loads of stats. Okay, because the models are different. So one may everything here, but some of them may be there and some others may not be in there. That is then all that I have for this session, but I know that this is a very introductory panel data estimation, and if we want more on panel data, then we should give more time, and we may need to actually see a hands-on extension of these things to better understand panel data models. With that, I finalize what I want to say, and I would like the organizers to invite people if you have any questions. Thank you.
Okay, thank you, Dr. Getachew. Thank you once again, Dr. Getachew, for the presentation. As we heard in the session, Dr. Getachew has presented two important things. One, he tried to narrate something about panel data. That means he starts from defining panel data, and then he exhaustively list out the very advantages behind having panel data and some issues to be fixed in the case of using panel data. So these all issues were raised or discussed by our speaker today, Dr. Getachew Yirga. That is the theoretical foundations behind panel data, advantages, and some stuffs or issues behind panel data. Again, Dr. Getachew also highlighted some important issues with regard to the estimation technique, how to handle the panel data, how to undertake estimation, and then finally how to report the results of a panel data estimation. There are a lot of techniques that can be used in estimating panel data, as you know. So Dr. Getachew, within this very short period of time, try to highlight important issues starting from declaring the nature of the data up to reporting the Stata result for various purposes. So I think the most important issues that we can grasp in today's session. So dear participants, if you have questions, you can raise your hand, and then the organizers will manage. Okay, are you hearing me? Some of the participants may respond. Are you hearing me?
Yes, we are hearing you.
Okay, Isaac, Wogayo, so you can manage.
Yes. Go ahead. We are with you.
Okay, thank you very much. There are some participants who have questions or issues. So Isaac and Wogayo, please proceed with the questions. Please help them to raise their questions. Hello?
Hello, Dr. Getachew. You can read the question from your chat box.
So till you organize, dear participants, till you organize your issues and questions, let me reflect on the issues raised so far in the chat box. Let me quickly recap for Dr. Getachew. Dr. Getachew, are you hearing me?
Yes, Snug, I can hear you.
Okay. So the first issue raised by one of our participants is how do we test pooled OLS versus random effect? Let me pardon again. How do we test pooled OLS versus random effect? The other participants can mute your speaker and organize your questions or stuffs, and you can raise later on. To begin with, Dr. Getachew can reflect on the questions raised in the chat box. The first question raised in the chat box is, how do we test pooled OLS versus random effect?
Okay.
Another issue that's raised in the chat box, you may note down. Another issue raised in the chat box is, what is the difference between longitudinal data and panel data? What's the difference between longitudinal data and panel data? Another issue is, what is the difference between balanced and unbalanced panel data? What is the difference between balanced and unbalanced panel data? So I think these are the issues that I capture from the chat box. You may begin with this, Dr. Getachew. Participants can arrange your questions meanwhile.
So much.
Okay.
So let me say a few words on this one. Pooled versus random effects is not automatically tested, as far as I know. So it can indirectly be tested. Okay, once you have the pooled versus fixed effects rejected or accepted, then you can compare that with random effects through fixed effects. So it's a matter of, okay, if we have, it depends on the gain of efficiency. Okay, efficiency is something that we, okay, maybe some people call efficiency gain as luxury, but if you want efficiency to be gained, and if you still want the panel data not to be lost, then you have to use random effects model rather than pooled. So it's not a matter of testing it directly. It's a matter of your, I mean, the decision is based on your requirements, I mean, your needs for your data. So the testing doesn't make a big deal, because if you, as I said, if you don't want the panel to be directly estimated, you may just simply pull the data. So random effects actually is very important in that sense, because it actually, technically speaking, it's efficient in the sense it has double or error components that can be used for the adjustment of the estimation. Panel versus longitudinal, as far as I know, there is no difference. Stata doesn't discriminate between panel data and the longitudinal data. If you go to the Stata menu, Stata says longitudinal versus panel data. So longitudinal and panel data are, for our purpose, the same. But we shouldn't discriminate. I mean, we should discriminate between pooled data and panel data, pooled data and the longitudinal data. That's
Yes,
what
please. You may explain that way, the difference between pooled and panel data.
Exactly. The difference is already said earlier when I started my presentation. When we say pooled, it is simply pooling every observation, I mean, eliminating the time variation. Okay. For instance, if I have, I mean, in our demonstration, for instance, we had 366 farmers, households, I should say, in 2005, and another 366 households in 2009. So by pooling a mean, I will add these farmers, I mean, these households together, and get 732 sample of pooled households. Okay, but fortunately for in our case, these are the samples that were followed together every 5 years, and if some, I mean, all of the households are followed over the past, I mean, over the 5 years, then I will have panel or longitudinal. But when I say pooled, it may not necessarily be that. Okay, they may be the same people or not. The good example here is the Ethiopian Demographic and Health Survey, DHS. Almost all of you know that survey. The DHS is not a panel survey, but we have 4 or 5 rounds of that survey, and the Central Statistics Agency takes, this is a very large survey. I mean, the sample size is huge. And if you are, for instance, there is a 2000, the DHS 2000, if your household is chosen in 2000, you may again be chosen in 2005. There is a 2005 survey. You may not. Okay. So if you are followed purposefully over the years, that is panel or longitudinal. But if you are not necessarily followed, that is pulled. But then panel data can be pulled. Okay, that's the difference. Panel data can be pulled. That's the similarity, I mean.
Yeah.
But all pulled data cannot be panel, because for panel is very specific. For panel data to, I mean, for a pooled data to be panel, you have to follow every observation over the years. And if this is clear, the other one is balanced. So the difference between balanced and unbalanced panel. So we are now rejecting the pooled one. We specifically focus on panel data. And that panel data can be either balanced or unbalanced. For instance, our data was balanced because, let me again go to that one and show you the comment result here. Stata is understanding automatically our data is strongly balanced. Why is that balanced? Okay. Because every observation, if I open my data here, every observation has a code. I don't know if you can see this, but I can increase the font size to, let's say, 14. If you have a look at here, unit HHID 0, the last one, 001 is followed in 2004 and in 2009. Look at this age. It was 60 in 2004, the household's head age, and now it was 65 there. Now, what we are doing is in balance. Okay, I'm not interested in the variables themselves, each of them, but we are interested in the follow-up of every observation over the 2 years that we have. If you have now more numbers of years, then the same number of observations should be followed the same number of years for your panel to be balanced. What does that mean, technically speaking? That is in the slides. If each unit is observed the same number of times, we can call our panel balanced. But if, okay, it could be the case, actually, I forced this panel, this data, I mean, to be balanced. Initially, when I get the raw data, it was not balanced because there was attrition. Attrition is in panel data, find a failure to be followed. Okay, if I was interviewed in 2004, I may dislocate. I may move to another place, and when they come to my place in 2009, they don't find me, and then the data is there in 2004, but not in 2009 because I left my place and they couldn't find me. Sometimes they may trace my location and they may ask me again, but then, okay, another reason could be I may die. Okay, the household head may die. The household head may be unwilling to respond in 2009 once they responded in 2004. So these are attritions, and I mean, may lead to attritions of some households, and this will lead your panel to be unbalanced. But you can create a balanced panel by actually disregarding or removing those that are actually interviewed in less number of years as the number of years, as the maximum number of years that you have. Actually, this is not good if the attrition rate is a lot. You have to take care because that actually may mean losing your sampling procedures, because if a lot of observations households actually left, the initial statistical procedures, the sampling, I mean, maybe actually it may be a different stat. So some panels will be, I mean, maybe discontinued because the attrition rate is a lot. For instance, this panel is now expired. It expired in 2009. They didn't collect the data after this year. I suspect this is because of attrition. In fact, there could be financial issues, but attrition could be one thing for our panel to be unbalanced. Some observations could be asked. I mean, you may get data on 2 years if you have 5 years data. Some may be interviewed twice. Others may be interviewed 3 times. That's what I say. I want to say about this.
Okay, thank you very much, Dr. Getachew. Others who have question, participants, or can I read for him the ones that is written in the chat box? Participants, do you have any other question or issue? So one question that's raised in the chat box is why FEGLS is more efficient than OLS? Dr. Getachew, you may reflect on this.
That's because of that double component and that error thing here. Okay.
Okay.
It's because of this. The weighting thing provides the. In fact, every GLS, if feasible generalized least squares, has some weight that actually will make the estimator to be efficient. Efficiency is related to variance, so
yeah,
it's that way. I'm not that good in hard stats, but I'm more into the applications. But my understanding is efficiency is related to that variance. Okay, this variance is going to reduce the variation in the estimators, and that will actually make them efficient.
Okay, Dr. Getachew, can you say something about issues like slope homogeneity and cross-sectional dependency? One of our participants asked like this slope homogeneity and cross-sectional dependency. I think the relationship and then how to estimate this. Few points.
Maybe if I get more explanation in this question, because I couldn't capture their relevance here.
Okay. Let me read as it is. Is there any relationship between unobserved effect, slope homogeneity, and cross-sectional dependency?
Okay, so maybe we give a chance to the person reading this question. I couldn't see it.
Mr. Dagan. Dagan. Can you present your question?
Hello. It's me first. May I continue?
Yeah.
Yes.
First, thank you, Doctor, for your very nice presentation. My question is to just, have some, look over the relationship between the so-called the unobserved effect and slope homogeneity and cross-sectional dependency when we are using countries panel data. And is it possible to use, or to check the so-called slope homogeneity and cross-sectional dependency in the so-called random effect, fixed effect models? That's it. Thank you very much.
What do you mean by cross-sectional dependency?
Mr. Dagan, how do you understand cross-sectional dependency? Just to make things clear.
Well, that's why I'm just asking this question. These are a bit new concepts.
Okay. Okay, Dr. Getachew, you say something about slope homogeneity and unobserved effect.
I haven't heard of this new term. Maybe I didn't update recently of these things, but if I get more explanations on this thing, then I could have replied to this.
Thank you very much. Another issue. One more question. Is education time invariant variable or not?
Sorry, Naga, what did you say?
Is education time invariant variable? This is asked by one of our participants. Education. In the meanwhile, the organizers can arrange the certificate for our today's speaker. The organizers, coordinators, you can arrange a certificate.
Okay. Hello, Naga.
Okay.
Some of the questions are out of our scope. For instance, when we talking about time invariant, simultaneously one is introductory part or simple or linear panel analysis. Please stick to answer our objective, depend upon the presentation, please.
Okay, participants, you can reframe your questions as per our today's presentation and session. You can once again reframe, and if I have questions related with this presentation. Okay, thank you very much.
Did I say something on the education thing?
Okay.
I think I was muted when I speak about it.
Okay, that's all.
Sorry. Okay, so the education variable can be both, because usually it is time invariant if the household head is already stopped. Okay, learning in the space of our panel data collection. Okay, the education thing is all about the numbers of years, or it depends actually. Here in our model, for instance, it's the number of years of schooling. So it may vary or not vary. If the household head is still, he or she may go to school after we already interviewed in the first interview session, in the first panel. For instance, after 2 years, when you started, he may be like just completed 12th grade, for instance. And after 2 years, if you go there and interview the household head, he might have earned a diploma or a degree, depending on what type of schooling he is attending, and you update that. So it's not necessarily time invariant education. Education could be any. So it depends on how it's household specific, and it depends on the data itself. Thank you.
Okay, thank you very much indeed for your nice presentation. Okay, participants, thank you very much once again for your active participation. Now the organizers can present the certificate for today's speaker, Dr. Getachew Yirga. You can show once again.
We already interviewed in the first interview.
This is the certificate, everybody.
Wow, thank you so much. That's interesting.
It's a reward for your today's study in explaining very huge concept of panel data analysis. Thank you very much once again for your service.
Thank you very much for your invitation. It's a privilege, really.
So now let's go to the closing speech as per the schedule. So before I invite for closing speech from India and Mizantepi, let me say a few points about Bardha University, because Bardha University Department of Economics is serving as the one organizer for this training. So as you know, by now we are celebrating our 60th year anniversary. So Bardha University is one of the oldest university, and it's lived as the first generation university in Ethiopia. As I told you, now we are celebrating 6-0, more than half a century anniversary. And we do have more than 200 MSc programs across all our 8 campuses. We do have 8 huge campuses in Bardha University in different directions of the town. And Bardha University is located in one of the beautiful city, Bardar city, which were nominated as educational city by UNESCO like 5 years before. And we do have also around 50,000 students in different programs, maybe distance, summer, MSc, PhD, regular, and other certificate programs. More than 50,000 students. By now we are hosting around 40,000 students in different campuses for regular basis. And with regard to our Department of Economics is one of the academic units that's in Bardha University. It's under College of Business and Economics. College of Business Economics in Bardha University, there are around 7 departments: accounting, management, marketing management, logistics, tourism. And from this, economics is one of the 7 departments in the College of Business and Economics here in Bardha University. And in the Department of Economics, we do have around 35 staffs, of which 10 are PhD holders, local PhD holders, 10, including the one who gave a speak today and 2 days before, Dr. Surafel and Dr. Getachew Yirga. So from this total 35 staffs, as I told you, around 10 are PhD holders, and we do have 7 PhD students from this 35 staff. And the department has 2 MSc programs in policy analysis, one, and development economics, the other, and 1 PhD program, general PhD in economics. Currently, we are having around 10 students in the PhD program and more than 30 students in the MSc program. So this is just to give you some insight about our university and specifically the Department of Economics, which co-organized this training for the last 5 days, together with our Indian partners and Mizantepi University, one of the youngest university in Ethiopia, but doing something like all the universities and some extent more than all the universities. So thank you very much, Mizantepi University, for initiating such a program, interesting program and timely program. Thank you very much, Mizantepi University. Now, let me invite our partner from India, Dr. Rajay, Dean of International Relations, Pune University, India, to undertake a closing speech.
Very, very good evening to all of you who have connected with us. Thank you very much, friends, for the 5 days faculty development program on research methods in economics using Stata software. On behalf of my university, Purnima University, I, Sudhi Rajiv, Dean of International Relations, want to thank you from the core of our heart for joining us. And also, it has been a pleasure to work with our host, College of Business and Economics, Mizan Chapi University, Ethiopia, in collaboration with the Department of Economics, Bahir Dar University, Ethiopia, and MATLAB Thinking Foundation, India. At the outset, I would like to thank Dr. Meher Chand, President, MATLAB Thinking Foundation, who has always brought all of us together on a platform for interaction, for learning and relearning. I take this opportunity to thank the members of the organizing committee, Chief Patron Dr. Kashum Muleti, Vice President, Academic Affairs, Mizan Chapi University, Ethiopia, Mr. Mulkin Chizau, Coordinator, Mr. Nega Ejigu, Girum Tenakur, and resource persons, Dr. Muktak Vyas, Getcha Yirga, Sarafil Mehbak, Yisak Nigusi, and Abu Bakr Hamid for giving their precious time and the effort that they put in to to put the whole thing together. It is because of their erudite presentations that we were able to run this 5-day FDP program. Earlier also, we have been associated with Mizan Tepi and MathTech Thinking University on a 5-day workshop on public health. And this is our second time, and we have enjoyed every moment of being together. I thank the audience, the faculty, the staff, researchers, students, practitioners for your commitment and your patience, and for the time that you have given to us. Let me tell you that this is not an end, but a beginning on your journey of learning, your journey of research. And thank you all for joining us. Thank you all for giving us this opportunity to share our knowledge with you all. Thank you, Dr. Meher Chand, for hosting us and for keeping us all together. I thank each one of you, the resource persons, the people who have chaired, my dear erudite colleagues who have chaired these sessions, the organizing committee, the patron, the chief patron, and all of you for making these 5 days worth visiting and revisiting. Thank you all very much, and I look forward to seeing you again and for more webinars, for maybe now we can even connect offline and get together, because now that COVID is, I can't say behind us, but not so threatening, I would definitely like that we meet sometime offline now and take our commandeering our friendship forward. Thank you. Thank you very much. Have
Thank
a
you.
very, very good night and have stay safe, stay healthy. Bye-bye.
Thank you very much, Dr. Rajab, Dean of International Relations, Purnima University, India, for your closing speech, nice closing speech, which narrates all the ups and downs that we have passed for the last 5 days. Thank you very much. Now,
Thank you,
let
sir.
me give the chance for Mr. Mulukan, Dean of College of Business and Economics, Mizan Tepe University, to present his closing speech on his part. Mr. Mulukan, are you hearing me? Mr. Mulukan?
Hello? Are you
Hello?
hearing me?
Yeah,
Yes. Hello, everybody.
you may continue, Mr. Mulukan. Continue.
Okay, thank you for giving this sense. Let's introduce myself first. My name is Murukan Tzazu from Mizan Tepe University Business and Economics College. And let me also add some clue about my educational background. My BA and MSc degrees, accounting and finance. Having said this, let's say something about our university plus our college. Business of Economics College, the former name for Faculty of Business and Economics, was established in 2000 Ethiopian calendar with the intention of contributing a lot in the areas of accounting and finance, in the areas of management, cooperative, and marketing. The program in college are enthusiastically to meet the university's missions of realizing career desires and producing knowledgeable, dynamic, and qualified accountants who are decided to serve various sectors of the country by integrating the different accounting principles and managerial models. A slide to the problem in enhancing the intellectual and economic validity of our country through the academic program, research and community other activities, producing graduates that can have adequate knowledge, skills, and attitude toward applications of management concepts. Plus that the college have also engaged in education for the sake of promoting the central growth of cooperative movement through its research, consultancy, and educational activities, with then builds problem solving, entrepreneurship, decision making, and cooperative skills. Plus that producing a marketing manager who is incapable in the process of planning, executing, conception, pricing, promotion, and distributions of ideas, goods, and services to create exchange that satisfy individuals and organizational goals. And clear and concise explanations, the College of Business and Economics have the following vision, missions, and the listed leading values. The missions of CBE or College of Business and Economics under Mizan Tepe University Ethiopia is to be one of the leading college in the country and be exemplary through the provisions of quality education, research and consultancy service in business and economics area by 2025. And it have this own mission that is enhancing the intellectual business and economic validity of our country through our academic programs, research, and community outreach activity. So this is all about the mission and vision of the college. And let me add some information about the basic data about human resource of the colleges. When, since its establishment, the college has enrolling more than 375 undergraduate students in a regular and continuous and distance education program. Right now, the College of Business and Economics has about 2,500 undergraduate and postgraduate students in regular and CDE program, continuous and distance education program. Plus to that, the College of Business and Economics has 126 staffs, of which 110 are academic staffs and 40 are administrative, and the rest two are technical assistants. Our college has good news for education seekers. In addition to its 5 existing departments and programs, our college has completed more than 85% of its work to open or to launch a new department, such as banking and finance program and the department, plus logistics and supply chain management program, department, public administration and development management program and department, and hotel and tourism management program and departments. Thanks to the academic sector for its follow-up and support about this. Let me add also one information about the program profile under College of Business and Economics. we have 5 programs in accounting and finance, cooperative economics, management, and marketing management. We have undergraduates and also graduate programs, postgraduate programs. In undergraduate programs, accounting and finance, BA degree in accounting and auditing, BA degree in business management, BA degree in economics, BA degree in management, BA degree in marketing management. And also in graduate programs, we have MSc in accounting and finance, MSc in project planning and management, MSc in development economics, and Master's Business Administration, MBA with 5 specializations. This is all about the college backgrounds. Having said this, on behalf of our college and our university, my thanks are as follows. In the first, in particular, I appreciate Kasahun Mulat, Academic Affairs Vice President of Mizan Tepe University, Ethiopia. Not only has this training been successful, but he has also been instrumental in organizing, supporting, coordinating, and collaborating with our academic colleges, as well as other colleges and universities in the academic fields, and he has been contributing a lot to the community outside the university by effectively fulfilling and discharging additional responsibilities given to him. Plus, my appreciation is also goes to Mr. Ogayo Mbialo, International Relations Partnership Directorate of Mizan Tepe University, Ethiopia, for his smooth, good, and timely communication with concerned and relevant stakeholders to bring the training plan into actual or realize. Next, my thanks also goes to Mr. Hisak Nuguse, a young, energetic, and committed economics lecturer and researcher of Mizan Tepe University under the College of Business and Economics, for the great contribution he has made by mobilizing, engaging the relevant lecturers, and most importantly, being the key resource person and the moderator for the third day training of this 5-day FDP training. Next, I would like to thank the national and international educational institutions that have contributed to the realizations of the purpose of this FDP training, such as Department of Economics, Mizan Tepe University, Ethiopia, Department of Economics, Bahar Dar University, Ethiopia, Purnamia University, India, Much Teach Thinking Foundation, the host one from India. You all, apart from expressing your friendship, you also show your partnership and your commitment for us. For this, I would like to say thank you all, and I firmly believe that we'll travel a lot together in the future. Next, my gratitude is go to resource person such as Getachew Irga, PhD, Department of Economics, Bahar Dar University, Ethiopia, consultant Food and Agriculture Organizations of United Nations and the World Bank, plus Rafael Melaku, PhD, Department of Economics, Bahar Dar University, Ethiopia, consultant Food and Agricultural Organizations of United Nations and the World Bank, Muktak Vines, PhD, School of Management and Commerce, Purnamia University, India, Isak Nuguse, Department of Economics, Mizan Tepe University, Ethiopia, lecturer and the CD or Chief Executive Directorate Office Head for Mizan Tepe University Teaching Hospital, plus Abu Bakr Ahmed, Department of Economics, Faculty of Social Science, Bayero University in Nigeria. Because you have given your precious time as a resource person by willingly sharing your knowledge with others in a sincere and professional manner. Therefore, my God, increase your knowledge and your understanding more. Then next, my gratitude is go to Mr. Groom Anker, Department of Economics, College of Business and Economics, Mizan Tepe University, Ethiopia. Mr. Naga Jigu, Department of Economics, Bahar Dar University, Ethiopia. Dr. Suhudi Rajiv, Dean International Relations and Professor of English and Soft Skills, Purnamia University, Juniper in India. Finally, I'm happy and proud to say congratulations to the trainees who has followed and completed this 5 days international FDP on research methods in economics using or applying Stata software. And I'm confident that you will use the knowledge you have gained from the training to conduct problem-solving researches that will have a large and significant contribution for yourself, your institution, your country, even for the world. Thank you for listening patiently. Thank you.
Okay, thank you, Mr. Multan.
Thank you.
Dean of College of Business Economics, for your nice and informative closing speech. Mizan Tepe, we should salute Mizan Tepe University. Really, Mizan Tepe University is one of the youngest universities in Ethiopia, but this university is doing great. So we should clap our hands up once, please, participants for Mizan Tepe University. All other universities should learn more. All others, the Israel University should learn more. From the initiatives taken by Mizan Tepe University, probably the staffs are our students, but they are doing a great job. So thank you very much for creating this platform, a nice platform to augment our international exposure, which is untouched in the other universities. So thank you very much once again, Mizan Tepe University. Coordinators, Mr. Isaac and Wagayo. If you have a message to convey for participants, it's time for you. Some important messages or notes for the participants. Isaac and Wagayo. Maybe the certificate issue, maybe the materials, how to distribute the materials of the trainings, all other issues.
Actually, thank you for your invitation for me as something behalf of Mizan Tepe University, as well as I am Director of International Relations and Partnership Directorate at my university. However, I am happy. I have no word to say something about this FDP program for me, as well as this work. Now, just I am requested to you. We have to share the certificate as well as some necessary document for you at night time. So you have to wait and you have to check your email. Even you have to back some feedbacks to be sent for you. Thank you. Congratulations.
Okay, participants. So the session is going to be concluded now. As you hear from
Thank you.
Ugayo, you can collect all other information and necessary documents by email, maybe today night, as per your request. So if you have something special comment, let me give you less than 1 minute for one of the participants. If you have special comment regarding this 5 days training, so that we can grasp some important lessons. Actually, the organizers have prepared a feedback letter or a feedback paper. You can finish that during the night, but if you have something which is special to be presented here on the face of all the audiences or participants, let me give you a chance, less than 1 minute. You guys, participants. If you think that the issue should be presented here. Okay, or else you will give your feedback for the organizers during the night time. Thank you once again, the resource persons and the coordinators, patrons, and really for your patience, dear distinguished participants. We appreciate your time, we appreciate your effort to grasp lessons given these inconveniences, given these all inconveniences. you were active participants for the last 5 days. So once again, let's claim for you, dear participants, again, for you also.
Thank you, Mr. Naga.
Yeah. So thank you very much. Goodbye, everybody. Goodbye, our Indian partners.
See you.
Goodbye, our dear Indian partners. Mizantep University, all other participants and resource persons. Goodbye.
Goodbye.
Thank you very much.
See you. Thank you all. See you.